Hello everyone, welcome to this video on practical demonstration of modules in Python. In last video, we have learned what is a module and try to use the concept of modules while developing an application using Python. So if you have not seen that video, just first see that video and then start learning this video. So in this video, we'll see how we can create a module, how to import a module and how to use modules, and we'll learn all these three things: how to create, import and use modules using a practical example of calculator app. So now let's switch to PyCharm for practical demonstration of calculator app and modules. So now in this practical demonstration, we'll look at how to create user-defined modules and how to import the modules that we have created. There are three ways of importing the modules. That is, we'll look at each of these ways of importing the module, and then we'll see how we can use those modules which we have created and imported in our application. So first of all, let us start with this: how to create a user-defined module. But before that, let us see how we can implement the simplest calculator. So we know that calculator app is nothing but an application to perform the operations like addition, multiplication, subtraction and division, and here we will implement that four operations, and we'll also see how we can use the built-in modules in this calculator app to find factorial of a number and how to find square root of a given number using built-in module. Here we have a file kc_main, which is a main file of this calculator app, and here we have integer variable x is equal to 4 and y is equal to 2. And say for example we want to perform addition operations. I can perform addition like this: s, that is sum, is equal to x plus y, and then I can print the sum s. So this is how I can perform the addition operation. Now let me run this program. So we can see that we are getting answer is equal to 6 because the sum of 4 plus 2 is 6. Now say for example I want to perform say subtraction, so I can implement like this: x minus y, and then here let us print it and let us see the answer. So here we can see that here we are getting the two results. The one is 6, that is addition of these two numbers is 6, and second is subtraction of 4 minus 2 is 2. We can make this calculator app more efficient and better by using user-defined functions. Say for example my function name is add, and to perform addition of two numbers we receive these two parameters over here, and within this function we will be performing the summation and will return the sum. Same way we can define a function, say sub, for subtraction x and y are passed as the argument to this colon, and we can return the subtraction of x minus y. Now we have defined two functions, add and subtract. So we have two variables and two functions, and now if we have to use these user-defined functions, we need to call this function, and we can directly call this function within the print statement so that it can directly call the function and print the answer. As the function add receives two parameters, so here we have to pass these two parameters x comma y, and same way I need to call this sub function subtract, and we have to pass two parameters. It will compute the subtraction of x minus 1 and will return, and here it will be printed. Now let us keep some appropriate message over here: sum of x plus y is equal to this, and similarly we can have appropriate message over here: subtraction of x minus y is equal to this one, sum of this one. And now let us run it. So here we can see the answer that sum of x plus y is 6 because 4 plus 2 is 6, and subtraction of x minus y is 2. 4 minus 2 is 2. Now say for example we have to perform multiplication, then I can keep the name of the function as say mul, right, and here just change the operator. And same way, say for example we want to perform division, so div xy, and here just we have to change. So now we have defined four different functions to perform each individual operation, and same way over here I can call these functions over here, and let me change this name. Say for example here multiplication mul of, and here let us change it to multiplication of x into y is this one, and now let us run it. So from here, these are the 4 print statement, and each individual print statement is calling this individual functions, and it passes the parameters x and y whose values are 4 and 2. And now let us run it. So we can see that. Now let us look at the result. Say addition of this 2 number is 6, as we have seen. Subtraction is 2. Multiplication of x and y, that is 4 into 2 is 8, and division of x by y is 2. 4 divided by 2 is 2. So this is the simplest implementation of a calculator. Means we are performing these operations which are performed by simple calculator, but here we are performing all the operations in one go. We'll see how we can perform individual operations as and when it is required. Say for example, if I want to perform only addition, then I should be able to perform only addition. If I want to perform multiplication of 2 numbers, then other operations should not be performed. So how we can achieve that thing? So we'll see later on how we can have that kind of implementation of this calculator. But right now this is a calculator app implementation without module. Now let us see how we can convert this calculator app without module into a calculator app with module. We know that this addition, multiplication, subtraction and division are the commonly used operations. So if we have such common tasks which needs to be implemented in multiple applications, so we can create a separate file. As we have seen that a module is nothing but a collection of functions, variables, classes and methods. So what we can do, we can create a separate file which consists of all these different files. The very first step is how to create a module, right? Let us create a Python file and let us give a name common_ops, means common operations. So right now it is an empty file and we can define all these functions. Let us copy these functions and paste it into common op. Let us have a comment over here, module to perform LC operations. So it's very simple to create a module. So right now within a minute we have just created a module performing these 4 operations: addition, subtraction, multiplication and division. So we have completed the very first step, that is how to create a module. Create a separate file and define all the functions required to be included as a part of the module. And here the name of the module is common_op. The second thing is, wherever we have to use these modules, we need to import this particular module. So we will be using those functions over here. Here just we don't have anything. Here we have just 2 variables and this print statement and call to this function. Otherwise we don't have definition of this function. So we will be using this common_ops module in this kelsey_main file. Now before using this module in a kelsey_main file, let me tell you how we can test this module, test each of the functions individually before using them into this file. One of the way to test this module is to use Python console, and here we'll be importing this particular module. So as I said that there are 3 ways of importing modules. Very first one is import individual function, class or variable. Say for example, I want to import only add function from this particular module common_ops. So the syntax is keyword from, the name of the module common_ops, then the built-in keyword import and the name of the function that we want to import. Second way is to import the module using an alias. The syntax is something like this: just import keyword, then the name of the module that we have created, then is keyword and then the name of the alias. So now once we have imported this module using this particular syntax, we can use this op as an alias or a short form to access all the functions within this particular module. Now the third way is we can import all the functions using this syntax, that is keyword from, then name of the module, then import keyword and star. Star means all the functions, classes and variables which are defined in a particular module. But here we have 4 functions, so all the 4 functions will be imported if we specify star. Now let us start with the very first one way, that is a from common_ops import add. Now say for example, I want to test this add function whether it is working properly or not. So what I can do, I can call this function using this value. Say for example 4,2. We are getting the error. The reason is this is a Python module and we have not imported this module till now. So now let us import that module like this. So now the module is imported, and again if I call this function using the same syntax, then we can see that we are getting answer 6. Means now it is verified that this function is working properly. Same way, sir, for example, if I want to perform subtraction, but it will give error. The reason is we have just imported only add function. Now let me demonstrate the second way of importing. So what is the second way? Second way is nothing but import keyword and name of the module common_ops and then is op. op is a alias of this particular module. So now we can use op to call, say for example, if I want to perform multiplication operation, right, multiplication of 4 comma 5, so it is giving error because we have not imported multiplication function from this, right. We have imported the package, imported this module with an alias, right. So here we have not used that alias, and that is why it is giving error. So if we use this op alias and then multiplication mul, and now let us use 4 into 5. So we can see that multiplication of 4 into 5 is 20. So we are able to use the function defined within this using this alias of a module like this, because we have imported this module and we have created alias of this. Same way I can perform the division operation, say for example 15 divided by 5. So it is 3. So now let us see how we can import the modules using a third way. So the third way is nothing but from keyword, then name of the package common underscore op, and then import keyword from this module. Import all the functions or methods, classes, whatever defined within that program. Now we will be able to use these functions without mentioning this op also. Say for example, if I use div like this, say for example here I give 20 divided by 4, so it is 5. Now if I use add, then I can add, say for example 20 comma 15. So now we are able to perform these operations. So right now we have imported the module common underscore op using all the 3 different ways, and also we have tested whether these functions are working properly or not. So this is how once a module is created, we can test the individual modules like this. An individual class or individual method or a individual function can be tested like this using console. If we run this program, now let us see what happens. So it is giving one error that name add is not defined. So the reason is we have not defined add function within this particular file. Now it is time to implement this particular second step within this particular main file. So that is the import the module using one of the ways. Here we will use the third way, that is from common ops import start. From common underscore ops import start means import all the functions. Now we have imported the module common underscore op, means now just observe over here that there is no error. But if I comment this one, now we can see that there are 4 errors. Here it is showing that there are 4 errors because in this file we have not defined these 4 functions. But if we import the module common underscore op where we have a definition of all the 4 operations, error has gone. So now if I run this program, we are getting the correct answer for each of the operation. Now let us change this value. Say for example here it is a 16 and this is say for example 5, and now let us run it again. So here we can see that 16 plus 5 is 21, 16 minus 5 is 11, and 16 into 5 is 80, and 16 divided by 5 is 2. So we are getting the correct answer. So here we have performed 2 steps, that is we have imported the module using the third way. Also we have implemented the third step, that is we are using these functions over here in printer, means we are using these functions which are defined in this module. So that is the third step, that is use of the module functions which are defined in module common underscore ops in the main file, that is kelsey underscore main. Now say for example I want to modify this kelsey application in such a way that if I type plus operator, then it should perform addition operation. If I type minus operator, then it should perform subtraction. And if I press small letter s, then it should find square root of a number. And if I enter small letter f, then it should find factorial of a given number. And if I enter e, then it should complete the execution of the application. So the very first thing we require is we need to read this choice, that is plus, minus, multiplication, f, s, or s, f, or e. So and that is why we have here one input statement. It will read the choice that we want to enter from the keyboard. Now depending on this individual choice, we have to check whether we have entered plus, minus, division, multiplication, s, or what. So we need if statement to check whether we have entered a plus operator. So if it is a plus operator, what we have to do, we have to call the add function and we have to print the sum of x plus y. And same way I need some other condition, I need to check the condition minus. So in short we need if else statement like this. So if the choice that we have read from the keyboard is plus, call the add function and print the result. If we enter minus, then call subtraction sub function and print the result of x minus y. And if it is a division operator, then call the division function from this module and then print the result of x divided by y. So right now we have implemented these 4 operations only. We'll see how we can implement the square root, factorial and exit from the application. Right now let us remove this. Let me briefly explain. So very first thing is we have already created a module and this is the main file. We have imported that module over here so that we can perform these operations within this particular file. We have 2 variables and let me keep, say for example, value 9 and say this is 3, and say here we have a menu. That menu tells me that if I enter plus operator, then perform addition. If I enter division operator, then perform division. So this is, in short, this is a choice menu. Fine. And then we are reading the choice from keyboard, and depending on my choice, it will either perform addition, multiplication. In previous case, what happens when we run a program, it was performing all the operations, but over here it will perform only the operations that we specify using the operator that we enter from the keyboard. Now let us run the program and let us see how it works. So here we are getting the menu and then here we are getting the prompt to enter. Now say for example I enter the multiplication operator and we can see that multiplication of x into y is 27 because the value of x is 9, y is 3, 9 into 3, that is 27. And finally it prints the message that by thanks for using the LCF. So that message we are printing over here. Now once again let us run this program again and let us see, again we are getting this right. And now this time, say for example I want to perform subtraction operation and enter this, so we can see that the choice is accepted. Then subtraction of x minus 1 is 6 because 9 minus 3 is 6. Now here what is happening, after executing the program it is coming out from this. So now I want to modify this calc in such a way that I should be able to remain in the loop. So it should run this calc application until I do not enter letter E from the keyboard. We should be able to perform all these operations again and again without exiting from the application. So we need a while loop before this. So while, and it should be in infinite loop, so we keep it always true, and it will be false when we, so over here if we enter any of these choice it will perform that operation. If we are not entering any of these particular choices, then it should come out from loop, that is it should break means come out from the loop. It will terminate the program execution. So now let us run it again and now let us see what is the output. So over here this is a menu and we are asking for the choice. Say for example I want to perform division operation, so division operator, and here we can see that the division of x by y is 3 because here 9 divided by 3 is nothing but 3. And again we are getting the menu and it is asking for the choice to perform the operation. And say for example this time I enter multiplication, so here multiplication of x into y is 27, 9 into 3 is 27. Once again it is giving the menu, and again say for example this time I want to perform addition operation, so we can see that sum of x. So here we are able to perform the operations as we want. If I want to perform addition multiple times, then here I can choose plus operator again and again. So my program execution is not terminated. But now if I enter E, so it will come out from the application and will display a message by thanks for using the app. Now the application is terminated. Now let's see how we can use built-in modules within this particular application. So first of all, let me comment out this code, and we want to use, say for example we want to use math module, right? So very first thing is we have to import this particular module. So import math and we can use the functionality. Say for example if I type like this dot, here are different functions that we can use by importing the math module. So we can find cos, cosec, degree, we can find, say we can print the pi also. Say for example if I want to print the value of pi, right? So just print pi and now let us run it. You can see that here is a value of pi with a precision of 15 digits. Same way, say for example if I want to find square root of a number, then what we have to do, we have to use it like this: math, the name of the module, and then the function that we want. So square root of a number, say for example here we have a number x is equal to 16, so and we pass this 16 over here, and let us run it. So we can see that we are getting the square root of 16 as a 4. Now let me change it. Say for example, if I have a 49, let us run it. So square root of 49 is 7. So this is how we can use square root, right? Now let me use some factorial function, fine. So print math dot factorial, and we want to find factorial of, say for example, 5. So factorial of 5 is nothing but 120, and now let us run it, and we can see that we are printing square root as well as factorial of a number. So we are finding square root of x is equal to 49, but factorial of 5. So square root of 49 is 7 and the factorial of 5 is 120. And if I change it to, say for example, 6, now let us run it again. So we are getting 720, which is nothing factorial of 6. This is how we can import a built-in module math, and we can use built-in module to find and square root and factorial of a number. Now let us see how we can implement these operations within our calculator app. Right now let us remove this from here. We need to import the package, as well as we need these two import statements. One is our user defined module and second is the built-in module math. And now let me remove the comment, and our code will be as usual, that is x is equal to 9, y is equal to 3, while loop, menu. As I said, that we'll be implementing later on. So now we'll add these two functions. Let me type it over here so that you can easily understand how we can if choice is equal to say for example s, then what we have to do, we have to print a message over here that sqrt, that is square root of sqrt of x, will take directly x is, and here we have to use that module, that is math.sqrt function. Directly we have to use over here and sqrt. Now second thing is if choice is equal to say f, then what we have to do, we have to find the factorial of a number. So here we'll see we'll find factorial of x is here we have to use that factorial function from math module math.factorial, and we have to find factorial of x. Fine. So we have added square root and factorial, and exit already we have implemented. Now let me remove this code, unnecessary code, and finally, right, we will be able to perform these operations. And when we enter E, it will break the loop and it will come out from the application, and finally it will print this message, and finally it will terminate the execution of this program. So now let us run it. So here our calculator app with module is completed, and now let us run it by pressing Shift F10, and here we can see the menu, and now we'll find the square root of a number. So enter choice S, so it will find square root of which number? 9, square root of 9, and let us see what output it is giving. So we can see that sqrt of x is 3 because square root of 9 is 3. And now let us change this to, say for example, 4. Now let us run it again. So say for example, if I want to find square root of this 4, right, then square root of x is nothing but 4, is 2. Now let me square root of x. So here I have slightly modified the code. I have just formatted the print statement. I have written like sqrt of x. Here I am printing the value of x in parenthesis is equal to this one. So this is nothing but formatted print statement. Same way for factorial also I have modified this print statement, and I'm just printing the formatted output. And now let me run this module again, and we can see that here is a menu, and now I have to enter my choice as a f to find factorial of a number. And right now the value of x is nothing but 4, so it should print the value of 4 as well as now let us run this program, and here we can see that menu is displayed and it is asking for choice. Now I want to find factorial, so I have entered f, and right now the value of x, it will find the factorial of x. Value of x is 4, so factorial of 4 is nothing but, just see what is it. It is 24. Fine. And say if I want to stop the execution, either I can enter E to terminate the execution. Say I have entered E, so it come out from the application. And say for example, if I change this value to, say for example, 16, and this to, say for example, 8. So now let us once again find the square root as well as factorial of a number, and let us run it. So here is a menu. Let us find factorial. Here we can see that factorial of x, that is 16, is this much, right? It is very big number. And now let us once again it is asking for a choice. If I want to find square root, then I have to enter s. So we are getting square root of 16 as a 4. And now say once again, if I want to perform, say for example, multiplication. So multiplication of 16 into 8 is 128. So here we have created a module consisting of these operations, and we are using the built-in module over here. So we have imported our user-defined module. We have also imported the built-in module math. So here we are using both kind of module, that is user-defined module as well as built-in module. Then the third step is the use of these modules. This is how we are using the user-defined module functions, and this is how we use the built-in module functions, SQRT and factorial, and we are able to perform operations depending on our choice. So this is all about modules in Python. Next video will be on built-in modules. We'll learn about these 5 modules in little bit more detail. Here we are ending this video. Thank you very much for watching this video. Have a great time.